Before we dive into the announcement, it's important to understand what particle accelerators are. The Large Hadron Collider, LHC, operated by CERN, is a 17-mile ring of superconducting magnets and the world's largest and most powerful particle accelerator. It represents the pinnacle of human scientific accomplishment. In point of fact, it is so powerful that it can recreate the very conditions at the beginning of the universe. But could this machine, designed to unlock the secrets of the universe, hold the key to something far more ominous? CERN, founded in 1954, is one of the world's most prestigious research organizations, with 23 member states and thousands of scientists. It's a hub for collaboration and innovation. The LHC is CERN's flagship project, but it's just one part of a vast network of accelerators and experiments. Imagine a racetrack, not for horses or automobiles, but for subatomic particles in a race, against time and space itself. The LHC accelerates protons to nearly the speed of light, sending them on a collision course that mimics the energy of the universe at the time of the Big Bang. These collisions cause temperatures 1,000,000 times hotter than the core of the sun. Thousands of magnets facilitate the proton's journey, while complex cooling systems maintain the magnets at temperatures colder than outer space. The beams inside the LHC are made to collide at 4 locations around the accelerator ring, corresponding to where 4 particle detectors are located: Atlas, CMS, ALICE, and LHCb. Each serves a unique purpose, exploring different aspects of particle physics. Together, they act as colossal cameras, capturing snapshots of these collisions. Scientists then sift through the debris, looking for signs of the elusive Higgs boson, also known as the God particle, and other phenomena that provide insight into the fundamental building blocks of the universe. By studying the microcosm, we gain insights into the macrocosm. But with every answer comes a new question, and with every discovery, a new challenge. The LHC is not just a scientific instrument. It is a testament to human curiosity and innovation. It embodies our relentless pursuit of knowledge and our desire to understand the fundamental forces that shape our universe. Yet, as we push the limits of our knowledge, we must also consider the ethical and existential questions that arise. What are the risks of investigating the unknown? Could our search for understanding inadvertently unlock forces in the holy places that we can't control? In the halls of CERN, where the boundaries of human comprehension are constantly pushed, a revelation has emerged that even the most well-intentioned, seasoned scientists find startling. Brian Cox, a former researcher at CERN and a voice of authority in the particle physics world, has recently made an announcement that has left the world both fascinated and fearful. Cox's words resonate with haunting clarity. The goal of the Large Hadron Collider at CERN is to recreate a mini Big Bang. Yes, you heard that correctly, a miniature version of the very thing that led to our universe. The physicist also went on to explain the implications of this goal, highlighting the LHC's extraordinary potential for making new discoveries. This includes its ability to unlock the secrets of the Higgs boson and explore dark matter, a mysterious substance that makes up a significant portion of the universe. Imagine holding the power of creation in your hands, the ability to conjure the very essence of the universe. It's a tantalizing prospect, but one fraught with danger. The mini Big Bang is not only a theoretical idea, but also a tangible reality within the LHC. The temperatures, the pressures, the raw energy mimic the conditions in the universe's infancy. It's like standing at the dawn of time, witnessing the birth of existence itself. But with such strength comes responsibility, and the question looms, what if something goes wrong? In fact, something terribly went wrong. Back in 1978, the Russian physicist Anatoly Bugorsky experienced a disaster that would forever alter the course of his life. While working on the U-70 synchrotron at the Institute for High-Energy Physics in Protvino, Russia, a malfunction led to his head accidentally entering the direct path of a proton beam. The beam, with a force that defies comprehension, passed into the back of his head, through his skull, and exited through his nose. Bugorsky's experience was otherworldly, a flash brighter than 1,000 suns, yet he felt no pain. The beam's path left a trail of destruction, burning through tissue and bone, yet he remained conscious and even walked to the clinic for treatment. The aftermath was both horrifying and fascinating. The beam's path led to the death of localized tissue, resulting in the loss of hearing in one ear and partial facial paralysis. Yet, astonishingly, Bugorsky's intellectual capabilities remained intact, and he continued his scientific career. This incident is not simply an individual tragedy, but a cautionary tale that underscores the immense power and potential danger of particle accelerators. The risks of a particle accelerator like the LHC are not to be taken lightly. The potential for unforeseen reactions, the very fabric of space and time being manipulated. These are not the stuff of science fiction, but real concerns voiced by some in the scientific community. One of the most alarming and captivating concerns associated with the LHC's experiments is the possibility of creating a miniature black hole. Black holes are regions of space-time where gravity is so strong that not even light can escape. They are cosmic vacuum cleaners, devourers of stars, mysterious entities that lurk in the shadows of our universe. The idea that the LHC could create such an entity, even on a microscopic scale, is shocking to both laypeople and professionals alike. This black hole could expand uncontrollably, swallowing the Earth from within. Though scientists at CERN have assured that any black hole created would be unstable and evaporate almost instantly, the mere possibility has ignited debates, fears, and a sense of awe at the power we wield. It's important to understanding how the LHC could create a black hole has to do with the fundamentals of particle mechanics. Accelerators activate when protons are smashed together at a rate close to light speed. The amount of energy released is so great that it warps the fabric of space-time itself. Imagine a trampoline stretched tight, and after that, a substantial weight is placed on it. The fabric bends and curves, and if the weight is heavy enough, it could create a depression so severe that anything in its vicinity would be drawn into it. That's a simple illustration of what might happen in the LHC in the world of quantum physics, where the rules of the universe are beautiful as well as bizarre. There is a theory that additional dimensions may be hidden within our reality. If these dimensions exist, the collisions at the LHC might use them, creating a gravitational funnel that forms a microscopic black hole. This enigmatic dance of particles has even caught the attention of some world-famous scientists, particularly the late Stephen Hawking. In his book, he warned of a situation in which the Higgs boson might become unstable at very high energy levels. This instability could lead to a catastrophic vacuum decay, a cosmic event that would not only destroy the Earth, but the entire universe itself. The esteemed British cosmologist and astrophysicist, Sir Martin Rees, also expressed his concerns about the experiments conducted at CERN. In his book on the future prospects for humanity, he explored the potential risks associated with particle accelerator experiments, including those carried out at CERN. His words were not merely cautionary, they were tinged with a sense of existential dread. He predicted the worst-case scenario, where an ill-fated experiment could create a condition called vacuum instability. This instability could, in theory, cause a phase change that would ripple through the very fabric of space-time, resulting in a cosmic catastrophe that could engulf the entire universe. Rees's worries were not unfounded, though confined to theoretical reflections. He assigned a probability to these catastrophic outcomes, albeit a low one, but even a minuscule chance, he argued, should give us pause. The stakes are unimaginably high, and the margin for error is razor-thin. The scientists at CERN have calculated the probabilities, run the simulations, and examined the theories to argue for the safety of the LHC. Brian Cox, himself included, acknowledged the importance of responsible exploration, recognizing that there are widespread fears and concerns surrounding the activities of the LHC. He stressed that there are strict safety measures in place, extensive reviews, and protocols that ensure the LHC's operations are conducted with the utmost care. Cox reassured that the energies involved are well within what the Earth naturally encounters, and the chances of creating a stable black hole are astronomically low. Even if one were created, scientists say it would be so tiny and so unstable that it would evaporate in a flash of energy, a phenomenon predicted by Stephen Hawking known as Hawking radiation. It would be a brief glimpse of cosmic wonder, a glimpse into the abyss, and then gone. Some have speculated further that the LHC's experiments could open a portal to a different dimension or universe. This notion, though largely dismissed by the scientific community, has captured the imagination of many and has become a subject of fascination, fear, and even folklore. What lies in the world beyond ours? Could we inadvertently unleash forces or entities that we do not understand? The idea of opening a portal to hell has even been sensationalized in media, adding fuel to the fire of uncertainty. But how exactly did this concept come about? What does it mean in the context of scientific investigation? The idea of parallel dimensions is not new in physics. String theory, a leading candidate for a single theory of everything, suggests that there are additional dimensions beyond the familiar 3 dimensions of space and 1 of time. These extra dimensions could be compactified or hidden from public view, but they could theoretically be accessed or revealed under extreme conditions. Now, imagine the LHC as a cosmic key, unlocking doors that have been sealed since the dawn of time. When protons collide at energies never before achieved on Earth, it could create conditions where the very fabric of reality is tested, and the doors to unknown realms are flung wide open. While the possibility of such events persists, it is vanishingly small. It's an idea that sparks the imagination. What if the LHC is, in fact, a door that leads not only to understanding the universe, but to realms beyond our comprehension? Could the experiment lead to a shift in our perception of reality, altering the very essence of what it means to exist? The world watches, captivated by the ongoing experiment, knowing that within the depths of the LHC, the potential for discovery is limitless, and so too is the potential for peril. As we ponder the implications of the Large Hadron Collider and its experiments, it's clear that the LHC is a sign that we are at a crossroads, a beacon of scientific achievement, a testament to human curiosity and ingenuity. It holds the promise of unlocking secrets that could change the course of our knowledge of the universe. But with this power comes the responsibility to consider the risks, the potential for unintended consequences, and the ethical dilemmas that lie in addressing the unanswered question: is humanity prepared for what we might uncover in the heart of the LHC? And if so, what will we do with the knowledge we gain? The answers may shape our future in ways that are hard to fathom,